Welcome to P4 in under 20 minutes. The topics in P4 are forces, motion, and energy. Forces are pushes and pulls that are around us all the time. When they're balanced, there is no resultant force, which means we may stay still or keep moving with a constant speed. When there is an imbalance of forces, an object will accelerate or slow down. During a crash, the force the driver feels depends on how long the crash takes place for. That's because during the crash, he loses momentum, and by the equation, force equals change in momentum divided by time. A crash taking longer means the driver feels less force. That's why cars have features such as crumple zones and safety belts to slow down the time that we stop for. Forces occur in pairs, and for every action there's an equal and opposite reaction. Jet engines take advantage of this because when they push the air backwards, the air pushes the jet engine forwards. As there's no air in space, a space rocket has to use a different mechanism. So inside a space rocket there's basically a big explosion happening. That explosion pushes out exhaust gas, and those exhaust gases in turn push upwards on the rocket. Still the principle of action-reaction. If I apply a force on an object to move it through a distance, we say I do work. I give that object energy. I know that, ouch, because I hurt my hand there. The amount of energy it gains is work done, force times distance. When an object's moving, it has kinetic energy given by half mass times velocity squared. And those are interchangeable. So, for example, an object falling to the ground may have kinetic energy, but when it hits the ground, that kinetic energy turns into sound. As I lift the object, it may gain gravitational potential energy, but when I drop it, that turns into kinetic energy again. When an object's moving, the reason why on Earth it usually slows down is because on planet Earth we have resistive forces. They come from things like air, and so eventually, because we're colliding with all those air particles, we slow down. All that kinetic energy then just goes into our surroundings. Because the kinetic energy an object gains as it falls is equal to the gravitational potential energy that it lost, we can actually equate those two formulae to find out its final velocity. So, kinetic energy, half mv squared, equals mgh. That means that v is equal to root 2gh. When an object moves through a distance, it's displaced from its start point. Now, displacement can be positive or negative, and it's only measured in a straight line. So when this man gets back to his start point, his displacement here is 0. And then as he moves away, his displacement is negative. Okay, negative. We measure an object's velocity by the distance it moves from its start point over time per second. So here, each second he's moving 1 meter away, so his velocity is 1 meter per second. If he slows down, then he stops moving a displacement each second and he just carries on stationary through time. And similarly, if he speeds up, his displacement every second will just get higher and higher and higher. If the object starts coming back towards its start point, then what we say is it actually has a negative velocity. Acceleration measures how quickly an object changes speed. If you look at this graph, it's important to notice that this y-axis is velocity, not displacement. So I'm going to show how the velocity of this object changes over time. So let's, for example, take something, starts off stationary, and then it speeds up to a velocity of 3 meters a second over a time of 4 seconds, well, the acceleration is the change in velocity. 0 to 3 is 3 meters a second divided by the time that took, 4 seconds. So it's 3/4 of a meter per second squared. And that's P4, forces, motion and energy.